Hello everybody, Mike here at Game From Scratch. With a brief hiatus of summer being over and Godot 3.1 taking form, today we are resuming the Godot 3 tutorial series. Now, a bit of a reminder on this one, there is a homepage available over on Game From Scratch. As you can see here, all the previous topics we have covered are already there. You see we've already covered nodes, GDScript programming, 2D animation, 2D sprites, 2D graphics, keyboard, mouse, joystick input, user interface development, sound effects and music, physics, and tiles maps. So we've covered most of what you need to create a 2D game, and we'll be moving on to 3D games shortly, but today we are going to cover networking. Now, if you from this homepage, which I will obviously link down below, you can go in and get the source code and assets used in each example, as well as a link to the video tutorial, such as the one that we are watching right now. On top of that, if you are a patron backer, first off, thank you. You folks are awesome, but I'm also creating a book, which I'll be making for pre-sale very shortly, but patrons have been getting chapters as I release them, as well as compiled versions of the book in progress. As you can see, the networking chapter that we're about to cover has already been made available to patrons. Eventually, the book will be available for sale, but if you're interested in grabbing a hold of it now, patrons do get that backing, do get that option. Also, I appreciate the backing. Thank you very much. All right, so without further ado, let us jump into Godot. Today, we are going to be looking at all aspects of networking using Godot 3, and there's quite a few. First off, we're going to be looking at creating a very simple client and a very simple server. We're going to do a socket connection over it using UDP. Following that up, we are going to look at HTTP requests. This is, you can basically create your own web browser for doing things like REST requests or using web services on the internet, or for remotely downloading files if you needed to, say, download textures off the internet for a part of your application, or if you wanted to self-update. That functionality is built in. Then we're going to look at a slightly more advanced client-server setup, where we're going to create our own client and our own server and do a connection between them, share some data. And then finally, we are going to look at the networking that is built directly into GDScript. So Godot has made networking simple for you for synchronizing across client and server using a set of keywords that are built into the GDScript language. So we're going to cover all of that today, quite a bit to get into. So without further ado, let's jump right in. Now, the very first thing we're going to do is create a simple network client. Now, we're going to be using UDP. Now, before we get too far into this, I should explain the difference between UDP, which is User Datagram Protocol, not a really telling name. There's UDP and there's TCP. TCP stands for Transmission Control Protocol, and there are two competing standards for how to send data across the internet. The simple way to think about it is UDP is light, fast, and unreliable. TCP guarantees that your packet gets where your packet is sent, assuming, of course, the internet in between works, but it has more overhead and therefore is slower. So if you don't care that the data makes it there and you want to run as fast as possible, you use UDP. If you want to make sure your data arrives, you use TCP. And you can use a mix of both. And the nice thing is, when we get to the higher level stuff, Godot abstracts this away completely. So it's something you need to be aware of, but it doesn't really change the world too much. So let's look at first creating our simple UDP server script. Now, I'm just going to do this via copy and paste. So let me just pull all this code in. That way you don't get to watch me do typo after typo after typo. So go on into the script editor. Now here, in a new project I just created, we're going to create a new script. We're going to call this, I don't know, server.gd. And here is, oh, that does not look good. Okay, 1 second. I got to paste from a better source. Okay, this is a much better iteration. So basically what we are doing here is we are going to be creating a UDP connection. You can see here with this packet peer UDP. Then what we do is start listening on the port. Now, it's very important to understand two kind of concepts you need for packet-based or socket-based communications. A socket is basically a connection between two computers on a port and an IP address. So you need an IP address, which is kind of the unique identifying location of the server, and you need a port. Now, you can think of an IP address the same as a phone number. So, you know, my phone number might be 555-555-5555, and then my extension within that phone number would be the equivalent of a port. So you need extension 555 at phone number 555, etc. So you can think of the IP address as, or an IPv4 address at least, as the unique identifying location of the computer you're trying to hit, and the port being the value between 1 and 65536 that is the unique individual, you know, extension for it to communicate across. So what we've done here is we've used port 4242, just because I like 42 for certain reasons. And we're connecting to 127.0.0.1. Now, 127.0.0.1 is a special IP address. It's called a loopback address. And basically, you're saying, on this computer. Now, if you were trying to communicate between two different computers, you'd have to somehow get the IP address of the remote computer and then enter it. With the loopback address, this 127.0.0.1, you're saying basically on this computer, make a request on this port. So that's what we've done here. We've basically started listening. So we created a socket connection to start listening on our local computer on port 4242. And you can see here, theoretically, it should just work and we should start listening on that port. And then we're going to basically just listen until we're done. So we're going to be done when we get the data quit. So when you type the word quit, we're going to shut down our server. Otherwise, we basically just read in the socket. We get the packet from the socket. The packet can basically be thought of a piece of information. To use another analogy, this is basically like a letter sent in the mail. And we turn it back into ASCII from its encoded format. So basically we're creating a string out of it. If that string is quit, we quit. Otherwise, we print out our data to the terminal. And then when we are finally done, we close down our socket. Now that's important because if you don't close down sockets are blocking. Only one application can use a port at a time. So unless you close down your socket, the next time you try to run this, that port will be in use. So we do shut it down when we were done, and then we end things. Now, you can, if you're on a Linux or Mac computer, you can easily send a piece of data over a port using a command line. Unfortunately, in the Windows world, it's not so easy. So this is server, and we'll save that. So for Windows world, we're going to go ahead and create another script now, and this is going to be our client. And the client's just going to simply send some data. And copy that out. So here, file, new script, and I will call this client, like so. And in this case, what we've done here is basically we create a socket connection just like we did the other time, but this time we set destination address, so we're going to reach out and touch somebody, the same address and same port that we created and listened to on the other machine. We send our message across, so in this case it's going to be your message here, and then we quit. Now the problem we're going to have here is we can't send that quit command, so we're going to have to do a little bit of trickery. So we've got these two competing GDScripts. Now we're going to just go ahead and run these from the command line. So first thing I need to do is go ahead and go to ctemp slash, actually here, c:/temp/godot/bin/ I built it from code. So we're running here just basically the path to your Godot executable. And we're just running these scripts from the command line. So once we've got the path to our executable, we're going to say run this script, which is done using the -s command. And then it's, where the heck did I put this? c:/temp/ here, show in file system. Come on. Here, I'll open it in the file manager. All right, so there's our path. So cut that down, go over here, path to our script, and then the first one we're obviously going to want to run is server, like this. So we now have our server running. So you'll see here on the command line, you see listening on port 4242 on localhost. So we're now listening for a socket connection. And we're going to need another terminal window to actually make the request. So once again, c:/temp/godot/bin/godot-s, paste, and client. So this is going to send the data. And let's go to our thing here. So there you see, our data was just received across the network. So there is a very simple socket-based set of scripts, really about as simple as you can make them. Now, obviously, we're going to want to switch that your message here instead to be quit. So we've updated our script. We'll go back here. We'll run our client script again. Now we're going to send that quit data over, and it should be done. And you see here, we've now shut down our server. So sending data across packets, quite simple, very straightforward. This is probably the simplest example I could make. Now let's look at using an HTTP request. Let's head on back into our project. We're going to open up our scene, and this one's going to be a we're going to do this one entirely in Godot from this point on. No more command line scripts. But this is going to be one of the most easy GUIs you've ever seen in your life. Speaking of which, let's just grab a font. Head it back in here. Boom, boom, boom. All right, so we're going to need that later. So let's go ahead and create a button. Button. And what we're doing now is just getting data from the server. So there's our text. Let's do exactly that. Get data from server. Let's update that font so you can actually see it. Wait a minute. Dynamic font. Let's edit said font. Now we bring in our data. Let's create the size at 24. All right, so there we go. So there's our button. When we click the button, we're going to want to go ahead and get data. So now let's go ahead and give our data somewhere to go. Just throw a label in here. Like this. Like that. All right. And I'm going to stay consistent with how I wrote it. So what did I call this guy? I called it label. Okay, that's straightforward enough. All right, so what we're going to do is when we hit this get data, we're going to go ahead and, predictably enough, go get some data from the internet. Now, we're going to need a URL to use here, some kind of a web services. And there are 1,000 web services. There might be a few billion of them at this point in time. But things like Facebook, Twitter, a lot of ad networks all work with web requests. So one example one I have found is this guy. This is a simple web service example service. So the URL we're using is jasonplaceholder.typeicode.com, and we're using the service /todos, and we're going to get record 1. And you see here, when you put that in, you get this raw JSON file back. Nothing really special going on, but this allows you to basically, the service you want to call is todos, the parameter you're giving it is 1. So if you want a 2, you see you get a different result back. And that's the gist of how services work, or how REST-based web services work. So we're going to want to be able to request this data across the wire. So let's head on back over here. We will add a script to our button. And sure. And now the code. And once again, I'm going to do this with the power of copy and paste. So what we have here is when we are ready. What did I do? Oh, yeah. So we're wiring up the request completed signal. So when our web request is done, this function is going to be fired. And at the point where it is fired, we get a couple of variables back. We get the result, we get the response code, we get the headers and body of basically the text back. So you're getting all your HTTP headers. And the big ones we're really interested in here are your response codes. These are your standard HTTP style response codes. So like 404 is not found. 302 is a redirect. What one we really want is 200. 200 means everything was A-OK. So that's why we checked that. If the response we got back was 200, then we're just going to go get to the body and turn the body from a UTF encoded string into a string that we can then apply to the text field of our newly created label. And then your big thing here you'll see is in the event that we press our button, we make an HTTP request and send it off. Now, of course, I need to actually add that. So we need to go on back over to our editor in 2D mode. And let's get out of full screen mode here with the child. I think, oh, did I make that a child? Yeah, I made it a child of the button. That doesn't make a whole lot of sense, but I'll stay consistent. All right, so HTTP request is a node type that is built directly into the Godot engine. And in theory, we should be good to go. So let's go ahead and run this. First run, so I need to set up my scene. Okay, code runs, get data from the server, and no results. Okay, no errors. Give me 1 second to figure out what I did wrong. Oh, I think I'm just an idiot. Let's head on back over here. Let's grab our button, and actually let's wire up our button pressed. I think that's all I did wrong. So, hook it up here, on button pressed, we'll connect it. That hits our on button pressed. So now when we press our button, it should actually, in theory, actually do something. So now let's test that out. Hopefully there's no more stupid errors. And here we go. Get data, and there you see. So what that did, basically went across the internet, grabbed some JSON data that we are now spitting out right here. Now there are also JSON encoders and decoders built into Godot, so if you want to turn this back into actual dictionary of data values, you can easily, but this is one way of getting data across the internet. Pretty straightforward, but you will find if you search for REST web services, there's an absolute huge ton of these. Now at the same time, this same control that we've used here, I'm not going to cover it today, but HTTP requests can also be used to just straight out download a file. So you can just say, okay, go get this file at this URL and save it locally, and then you can use it just like any other file in your project. So if you want to make some images or textures or things that are remotely settable on the server, or if you want to give the end user some level of customization, you can use it via HTTP requests to grab and download those files. Now do be a little careful though when you add this functionality if you're on iOS, because Apple in their walled garden, they sometimes prevent this kind of functionality. But that is simple HTTP request. One thing to be aware of, this example did not require HTTPS. If you do require HTTPS, you have to get an SSL certificate. Now, great thing is this functionality is built into Godot, but we're not going to be covering it today. So do be aware, if your URL is an HTTPS URL, you need to use it according. Oh, actually, in this case, I didn't, because what I had to do here was basically pass in this false. Otherwise, you need to pass in your SSL certificate so that the line you're on can actually be encrypted. Okay. So that was HTTPS request. Now we're going to go ahead and create another demo with a very simple server and a very simple client that we're going to build directly in Godot itself. Now we're ultimately doing kind of the same thing we did when we made our basic server before, but this time we're going to let Godot take care of a lot of the niceties for us. It's going to be using an underlying package called ENet, an open source package that Godot has done an implementation of. So what we're going to do is create two separate projects, one for a client, one for the server. And you don't need to separate it out this way. It's quite common to have a client and server be ultimately the same executables. But in this case, it made some sense to me. So that's how we're going to go ahead and separate these two out. So right away, let's just go ahead. We'll reuse this project. Actually, you know what? Let's do it from scratch. So let's go back to our project list. And first things first, we will go ahead and create our project. C:/temp server YouTube. So this is going to basically be the computer that we are connecting to. We're not going to do a whole lot here. The server is going to be able to send messages out to the connected client. And that's kind of about the extent of it. But this is going to show you how to manage connections, handle connections at a slightly lower level, and how data can be sent across using ENet. So now we need to go ahead and create our server. We're going to create a 2D scene like this. We're going to go ahead and add a label. We will name the label status. And we'll add another label. And we will call this one label user count. And that is kind of the extent of our UI. So UI there, put status down here a bit more. Now, let's attach the script to that first, the status label. So we're going to go ahead, create a new script, and we'll attach to it Sure. And this is going to be where we set up our networking. I know in the grand scheme of things that makes absolutely no sense, but in this case, it works quite handy for me. And what we're doing here is basically we're creating our network, and then we are basically going to start listening. So this is kind of like what we did before. We're going to create a server that listens on a given port, on a given IP address, which is your own IP address in this case. And then there's a bunch of callbacks that are called when certain things happen. So you see right here, we created our network, and this time we're using network multiplayer ENet as the class for our networking. Like I said, this is an implementation of the ENet class, open source library. It is possible to use or create your own networking, so there is a layer of abstraction there that Godot is providing, but the only implementation they currently have is this ENet one. And then we start things off, we create our server. This is a lot like what we did before, but we're just not dealing with it at the port level. We're going to say listen on port 4242 and limit it to a maximum of 2 connections. Now obviously you could jack that number way up if you wanted to have more people connecting. You'll notice here, though, that networking is inherited from the root tree. This is important. The root tree holds a class called, what the heck is it? Packet peer. So it inherits from a class called packet peer. It will automatically be part of your tree, and the root tree is very important to networking in Godot. So basically, we're creating our network right here. Done. And we're going to see the very similar thing in our client code. So now what we've done is wired up 2 signals. We're going to listen for connected and disconnected signals. In the event that connects, we basically just print that out to we update our total users, and we print this out to the status string, or to ourselves. You can see over here, we're doing it again. You can get the number of people that are connected by calling get tree, get network connected peers. So that networking is all wired into the root of that scene tree. Very important to remember that. So when someone connects, we print it out. When someone disconnects, we print it out. And I think that's it for our server. So in theory, we should be able to run our server after I save it. So server, excuse me. All right, not the most exciting thing you've ever seen, but there our server is now theoretically running. Let's go and run our other. So now we need to make our client. So fire up another copy of Godot. And once again, I'm all doing this entirely local computer using 127 loopback, just because it's a lot easier to demonstrate. Demonstrating networking over a screen capture is tricky otherwise. So now we're going to go ahead and create another new project. We'll throw this one in client YT. Create that folder. Create our project, and here we go. This client is about as simple as they're going to get. We're going to have a pair of buttons. Button. The hardest button, the button. All right, so there's button 1, and we shall dub the button connect, and put that there. Let's grab our font. Drop that there. Connect. You can read that. I'll leave it as it is. And then we will, oops, right click, duplicate. And this obviously is disconnect, like that. And where did my controls go? Oh, there we go. Now we're going to do this as a series of scripts attached to our project. So here in our root node, when we load up, we're automatically going to connect to the server. So let's go ahead and do an attach script here. Sure. And we want to do is this. So when we are added to the scene, when we are ready, we basically create a network multiplayer ENet, exact same thing as before. This time instead though, earlier, you'll see we did a create server. This time we are doing a create client. We're connecting to the IP address, the loopback address again. Again, if you were using network machines, you would use the remote address in this particular case, but then also you would have to worry about firewall issues, all that stuff. I'm not going to deal with it. And we're connecting on port 4242. Once again, we use the set network peer to pass in our newly created network. So you'll see the code works identically, client or server, with the only real difference being this call right here. And we handle the connection failed event by basically spitting out that a connection error occurred. And now we can go ahead and wire up our buttons. So when we want to connect here, attach a script to that guy, create, and zoom. Pretty straightforward. When we press our button, we create the client. We're basically doing, again, the same as connect before. So disconnect. Disconnect's probably the more important one to show. So add attached script. When you disconnect, what you do is simply say set network peer, and you pass in null. This will effectively close that port, close that connection, and you are off to the races. So now the only final thing I really need to do is remember to actually wire these guys up. And wire this guy up. All right, so in theory, our client is now ready. Okay, so now we have a client that when this scene is shown, it will automatically connect. Oops, I forgot to label my text. That's confusing. All right, so over here, our server, you'll see there, shows we have a new user connected, and it shows the unique ID of that connection. That unique ID is going to be important later on if you want to communicate specifically to just one machine. You use that detail right there. So we're now connected. We can disconnect, and you will see here, it will say it's disconnected, and we now have 0 users connected. So pretty straightforward, pretty easy to work with. We'll leave our, actually I think we're gonna need to shut them both down. So we'll shut down our server, we'll shut down our client. I'll change this before it gets too confusing. So this button instead does a disconnect from now on. All right, that makes sense. So now what we're gonna do is give the ability to send some information from the server to the client. And this is done via, all right, so we're gonna need a GUI for that. So let's go over to this guy, all right. And we're gonna need to do a little bit of work here. So let's go back over here. We'll update our wonderful user interface. So we're gonna go ahead and add a new child. I think it's called a line edit, which is basically a text box. Add that into our world. This is the data we're gonna send. I will call this text to send. This is where we enter our text that we want to send. And then finally, we will go ahead and add another button. Oh, I did not want to make you a child. There you go. Button, send data. And this guy is now going to need a script attached. And to send data, we simply do this. So we're basically encoding the data. So first we get the data from the text field, and then we encode it to, you can use ASCII or UTF-8. So we've encoded it down to bytes. And then we use this built-in class that is off of the root called multiplayer, which is an instance of multiplayer API, which is an abstraction of cool and handy stuff you need to do with multiplayer, such as sending bytes. So this function will send the data across to the server, or sorry, to the client. So all I need to do is wire that guy up like this. So now our server should be able to send data. Let's go over to our client and give it the ability to receive data. So here, go ahead and add label. Put that down here like this. We will call this guy did I call this guy? Label server data, like so. So now what we need to do is come back into here. So we're in, this is the, when a connection occurs. So far we've only wired up connection failed. Well, now we need to actually handle another signal that comes in on the network. And that is Actually, it's on multiplayer. So we want to wire up to handle this guy. So basically, when network peer packets arrive, we're going to call this function. And in that function, all we are going to do is call this. So when that packet comes in, we get the ID of the server that sent us the packet and the packet data itself. What I'm going to do here is I'm going to switch this out, and instead this will be label server data.text equals like that. Label server data is not, oh, $. All right. So there we go, basically. Now we've wired it up so that when a packet comes in, we print the contents of that packet out to our text field. Now, of course, there is no error handling here. There's no multi-packet. So if the packet was too big, things get split into multiple packets. I'm not dealing with any of that stuff. So if you want to dig into it with more detail, if you start getting into more complicated stuff, do be aware there is more involved. I just don't want this video to be outrageously long. So I'm leaving a lot of things out in that regard. But you get the gist of it. You should be able to extrapolate from there. So we got our client going. So let's fire it up. I thought I already did this. Okay. So our client is now running over here. Let's go ahead and fire up our server over here. There we go. It's client, server. Here's my button. I did something wrong. Just a sec. Did I not add any text to my button? Did I not create the button? Oh, I just sort of stopped mid-button. Okay, let's actually make our button work. So, inspector, send data. Sorry, my bad. Did I wire this guy up? I did. Okay, so now we have an actual button to press, and let's go ahead, start that over again. So let's run our server, run our client. So server is up and running. You'll see there the client already started, so you see there's one user connected, and that user is that connection right there. So show our client. There's our client. All right, so head back over to our server. And I'll say, how's it going over there? And send the data. And kaboom. All right, what did I do wrong? I'm going to get index on null. Okay. Guess it helps to actually use the same name. So what did I call this guy? Text to send. Text to send. All right, so I will pause and get everything fired up. Okay, and there you see when you don't have the mismatched names, the data is sent across from the server to the client. So we can send whatever we want. Really, whatever we want. And send data. And there you see the data is being sent across. Again, this is a very, very simple example, but you are seeing two computers communicating with each other using a somewhat low-level version using ENet. Now what we're going to do is get into the GD specifics of the GDScript extensions that Godot have made. And basically what you can do is synchronize a scene between machines. This kind of gets confusing at times, but hopefully it will make sense when we are done. So I'm going to just jump in, shut down this guy, and we're going to create a brand new project. So let's go with this one. We'll quit to the project list. So this example is going to be just one application. No more of this separate executable for client and server, even though that is a nice logical way to think about the separation. Instead, what we'll do is we will call this one /temp. We'll call this networked game demo, and we'll create that out. And all we're going to do is basically create a network game that runs across two computers where you can control movement on one guy and it'll update on the other. You control movement on the other guy and you can update it back on the original. And that's about all we're going to try and accomplish here. But first thing we're going to need to do is create a lobby. So that's what we're going to start with. This is where your networking would generally come in. This is how you determine who is the client and who is the server, kind of like you do with any multiplayer game. Someone hosts it, someone connects. In this case, we are going to host. We're still going to be using the loopback because it's all going to be operating on this one computer. So let's start by making our lobby. We will call this guy lobby. Let's go out to the lobby. And then what we're going to do is just basically create two buttons. So first button, this, and boom. Let's bring a font in. All right. So this guy will host our game like that. Let's change that font up so you can see. Okay. $32 points. Okay, that looks good. So this is our host game button. Let's call that. I think that's what I called it. Every time I minimize the screen, I lose this guy. Yep. So we got button host, and then we'll just go ahead and duplicate this guy. And button join. Not the greatest lobby you've ever seen in your life, but it is most certainly a lobby. Now what we're going to do is go ahead and create a script and attach it to our lobby. This. And now we start implementing our server. So where's my mouse? There it is. All right, so let's get rid of all this junk. And the first thing we're going to need to do is handle when a network connection actually happens. So that is in our ready function. We implement this. Now what we're doing is wiring up the network peer connected to a function called player connected. Now we should probably go ahead and actually implement that. So this is when a player connects to the server. When the player connects to the server, you notice an ID is passed in. This is the same ID we saw print out in the previous example. This is a way of uniquely identifying a client on the network. And what we want to do is save it in our global. Hey, what global? Well, let's make that. So now we need to create a new script. I will call this globals.gd. All I'm doing is creating it as an auto load. If you haven't already figured out how to do auto loads, I did this earlier in my GDScript 101 chapter. So globals.gd. Okay, so now we got to implement this guy. It's about as simple as they get. All we're doing is setting the other player's ID to -1 to start. So we've got globals available to us. Okay, save my scene, that's fine. Save my script, that's fine. We need to actually configure that auto load. So you go into projects, you go to auto loads, you go to add. Oops, you browse to it first. So our GDScript is automatically loaded. So globals will load when our project starts. So this is just basically a global available variable of our connected players. If you had multiple players, obviously you would just create this as a table or an array of players. But in this case, we're going to hard code it to just one player. So we're going to have the server and we're going to have the client, and that's it. So back to our code. So what you see here is basically when the game starts, when someone connects to us, so the network peer connected event will fire, we save their ID, and then this is critical, basically, and this will fire on both machines. What we've done here is we've preloaded game.tsn, a scene we're about to make in a few seconds. We then attach it to the root, we make it the active scene, and we hide the lobby. So pretty straightforward. Basically, when a peer connects, we automatically start the game up. Now, let's go back and handle those buttons. So over to 2D, on host pressed, node, signals, on pressed, and we'll wire this into lobby, and we'll connect it there. So now we want to implement this function. So on button host pressed, yeah, wording is the same. I will copy and paste again. When we host our network, exact same thing we did earlier on. Basically, we were creating an ENet account, we create our server. If everything works fine, then we'll hide the join button and disable the host button. That way we can just see which one is the server visually. And this key one here is we also set the network to the host. Now, this is the exact same code that we did earlier on. And we're going to find that the button join is also almost identical. So we're going to go ahead, connect that into our lobby. But in that particular case, the join button, we use this code. And same logic, once again, we're doing a create client instead of a create server, but already the same thing that we already covered earlier. And at this point in time, we should, in theory, have a complete game setup. Now, all we need to do is actually have a scene that we can move to. So we're going to go ahead and create a new scene. to be a 2D scene like this, and let's go back to it, and we'll save that scene. So this is our game. Did I do plural? Yeah, game. So we'll head on back over to our scripts. So that is this. That is what, when our player connects, the one that we're going to switch to is the game scene that we just created. And hopefully this error message will go away now that that is there. I don't know how long that's going to take, but we should be good to go. So let's test things out. So we're going to need, and this is where networking kind of gets kind of crap. What we need to do is build an executable version to run as either the client or the server, because you can't easily have two instances of Godot running the same application without it getting a little pissy. So we're going to have to go ahead and build this. I haven't actually done this on this machine yet, so I'm going to have to bring in the export package. I'm going to cover this process at a bit of a later date. So we need to add preset, and we're just going to create a Windows desktop executable. I'm not going to show you this part. This takes a bit of time, so I'll be right back. Okay, so a lot of magic just happened off camera, but basically I just installed the export templates that allow me to compile for the Windows platform. Now, it's something I'm going to cover at a later chapter, so if you don't know how to do that, I will do a tutorial on this shortly, or you can find one online. But basically, I build my executable, so basically we just do export project. This will create an executable for us. I've already built it, so we are now good to go. So now we've got a version we can run, which I'm going to go ahead and do now. So this is the compiled version of my game. So here we've got one instance. I'll bring this guy up here. Head on back over here, and we've got our other instance. All right, so we now have room for a client, and we have room for a server. So I'm going to create server over here now. So we're waiting on, so hosting network, you can see right there. So now our client is going to connect to the server. And boom, we've just loaded up our game. Now do keep in mind that our game is complete and utterly empty. So now let's work on that. So let's shut this down and get back to creating our game. So game over here, there's not gonna be a whole lot going on in game. In fact, nothing is gonna be going on in game. So our empty game like this, it's all going to come down to the script. So let us create that script. So here is our game. I didn't know if I named this thing anything. I don't think it matters, but here, we'll call this game root, just so we know. And we will go ahead and attach a script to this guy, like this. So game, and here's the code we are going to use. And what we're doing now is instancing two objects. One is our local player, the other is the remote player. And we're gonna have to create player.tscn in a second, so that's gonna be the next scene we're gonna create. So what we've done here is pretty much just created a new instance of a scene that is our player character. Our player is just going to be the Godot logo. Nothing to get too excited about, but the key thing to understand here is this guy. So setting the network master, this is basically saying, on the network, the person who owns this machine is this person, or more specifically, this machine. Now, remember I told you all about those unique IDs that we've got when we connected? Well, this is why we saved them. So in the case of our server, we're going to use our local ID. We can get that by calling getTree, getNetworkUniqueID. So the ID of the server will be used in this case. But the server is also populating the remote one. And this is where our global, this is why we saved the unique network ID of the client. So if you had multiple clients, you would basically populate this one in a list. But the key thing is that remote client is going to own its own instance of the player. Okay, so that's it. That's all we're going to do is when our scene is populated, we created the two player objects. So now we're going to need to go ahead and create that player class. So new scene, empty. Switch over to 2D. So this is a 2D scene. We'll call this player. And let's save that guy. What's your issue? Oh, can't find player. All right, that's because scene, save this scene as player. All right, so we've got our player in the world. All this guy really has is a sprite attached to it. Like that. And that sprite is just going to be our default icon. Oops, I need to actually, stop that. I need to actually select it first, icon, and then boom. So our player is just the Godot logo. Nothing really magical happening here. But let's attach a script to our player. So player.gd, and this is where the magic is going to happen. Let's get rid of all of you. And now let's move over and grab our new networked code. All right, so our code is in. I will come back and look at it in just a second. Let's make sure that everything is working. So first, we're going to go ahead and do an export, create our project. So there is either a client or a server, doesn't really matter. And, okay, so we built an executable. So we'll run a version. We'll switch back over to Windows, and we will run another instance. All right, so we have 2 instances. This one will be our host. It's kind of important to be the host for the one that you're running from the debugger if you want to see the output results. And here we'll join the game. So there what you see is not what I wanted. Okay, so this one works. We can see our end result. This guy did not work. So I made an error somewhere. Give me 1 second to figure out what I did wrong. Okay, seems to be a bug with the exporter. For some reason, I developed this code on macOS. It doesn't exist on macOS. It does on Windows, but I'm running a beta build of the exporting templates. So perhaps it's just that. I won't get into the details, but I switched out the image that we're using and set the export templates and blah, blah, blah. So we should be fine now. So go ahead and run both. So in this case, I'm going to host our player on the client. I'm going to join the game. And now you will see over here, I move around and you will see that version is being moved on the other person's computer. And then over here, same deal. So we've actually set it up so we have synchronized game objects between 2 games with a basic lobby system, pretty much everything you need to get started with networking using the Godot game engine. Now let's take a look at some of the details. Now coincidentally, I can also hit the Q key and boom, it all shuts down. And I'll show you how all of this works now. So we got to head back over to scripting, and this is all attached to our player. So this is the object that we instanced in our game. So we created a player for the remote and local machine, and each network computer is in charge of its own player object. That's very important to understand, and that was set using the set network master. So now let's look at how the code works. Pretty straightforward for the most part. There's no constructor, so what we're doing here is in each pass through the game loop, we're moving it around. So the first thing we're going to check is basically, do I own this game object? And if you do own the game object, we want to pull for input. If you don't, it means it's a network game object, and all you want to do is move it to whatever position it's at. So you can see the move bar being set this way. So what we're doing is if we hit left or right, we move 5 in whatever direction. We've covered this kind of code over and over and over again. You'll notice also if we hit the Q key, we call the function called shut it down. And this is what exited the code on all of the machines attached. And the key magic is this call right here, RPC unreliable. And what we're doing is we're invoking the function set position using RPC. Now, RPC is a way of communicating across machines called remote procedural calls. And you can think of it as a way of making a function callable across the network. And we have set the position function. We have created a set position function that is network callable. So how did we do this? Well, when we declared it, we called it slave. Now, you'll notice there's a bunch of magic words going on here. There's slave, master, sync, and then remote, which I didn't use. And we're going to look at exactly what those mean. But basically, all we've done here is we've called set position on all attached clients. And that's what this call right here does. Now, those calls are the magic. Those are where all the network works, through these keywords. This is what exposes functions for being called from other connected computers. And you can basically look at it this way. A slave is code that will run on the remote computer. A master is code that will be called if you are currently, so if this is true, if you are the network master, that code will run here. So this is basically being sent to everybody. We're going to look at how to minimize that in a second. Now this one, sync, is kind of magic. This is for running it both on the remote and on the local machine. And then the final one is remote, which would cause the code to only run on the opposite machine. So if you call a function that says, if it was remote function shutdown, that code would only run on the connected clients. It would not run on the local machine. So that is your 4 different options for synchronization. You've got sync, which is on all machines, remote, which is on only faraway machines, master, which runs on the network master, and then slave, which is basically everyone who isn't the network master. And through using this combination of keys of code, you can basically synchronize across different machines. Now, one thing that's kind of important here is notice we've got this shut it down call. And a lot of times you're not going to want to have everybody and their dog able to issue commands like this. You don't want everybody to be able to do code that you only want to confine to the server. And the server and the network master are different things. Network master is just the owner of the game object between all the shared instances. The server is the authoritative one. So if you want to make it so that only the server can shut things down using the Q key, we can change this one out to basically just go if, and then we want to use the function is network server. And that will only return true if you are the server. Now, the server, again, was defined by the one that was called using create server as opposed to create client. So this makes the server authoritative. It makes it that only the server can run that particular code. And using that if statement is basically how you'll be able to limit it so that only authoritative stuff can run on the server. For example, you want to cut down on cheating and you want to make it so only the kill player code can run on the server. You just put it behind an if is network server check, and you are off to the races. Now, the final thing that we're going to cover on is this call. This is what actually sends the request across the wire. What this says is RPC unreliable call to set position. So we're looking for a function that has been tagged as networkable, so either sync or remote or slave. That will call that function across the wire, and here is the set of parameters going to it. Now, one important thing is this will actually broadcast to all connected clients. Now, in this case, we only have one client, one server, so it's only going to go to one person. But if we wanted to strictly limit it to just one person, you put the ID here, and then only that computer will be connected. So if you want the server to selectively talk to or to only talk to one machine, you just pass its ID in with these calls. Now, this RPC unreliable, this underscore unreliable part is also important. Now, remember back when we started all this, I said there was UDP and TCP, and Godot took care of the difference for you. Well, this is how it takes care of it. Unreliable is a UDP call. If you want to call the exact same thing, just use RPC. The same file parameters, you can also pass an ID into it, and this will use TCP instead of UDP for making the RPC call. Now, in addition to RPC, we've also got rset, like this, and rset unreliable. These also use UPC, but instead of calling a function on the other end, what you do is pass in the name of the variable you want to update, and then you pass in the new value of that variable. And then again, in this particular case, you have the option, this will update that variable on all connected machines. You can also pass in a specific ID and communicate with just one machine at a time. And I know that's a lot to take in. I know this whole master slave sync and remote stuff is a little bit confusing. Hopefully the RPC and RPC unreliable and rset unreliable make sense because of the UDP and TCP stuff we already covered. But this is a daunting amount of information. And on that topic, I'm already at 50 minutes, so I'm going to cut it there. One last thing I do want to mention to you is if you head on over to Godot site, like so, and go over to downloads, you'll notice there is a special version available right now on Linux only called Server, and that's going to be coming to Windows and Mac OS in the future. And this is a special version of the Godot game engine that doesn't have the UI or tools built in. So that means there's no rendering done on that end. So what you can do is you can create your game exactly like what we've done here, and you have all the logic there, but it doesn't have the same overhead. So if you've got a dedicated server, you can use this coding structure and have it synchronized with all the rest, but all it is going to do is the server stuff. So all the rendering stuff, the UI stuff, this stuff is all not included in that build, so it can host more connections. So if you're looking at creating a MMORPG or you have your own dedicated lobby or networking, you can use the headless version, the server version of Godot. That is just a version of Godot built with the /server tag in the build process. I'm going to be covering building Godot in more detail later on. I've actually already done a video on it in the past, but I'll make sure I cover server builds in that. I've been informed by the developer team that this builds for the Windows server are going to be coming soon as well. So if you want to have a server version or a headless version of Godot without all the UI stuff taking up resources when it doesn't need it on the network end, that is an option as well. Okay, that is it. That is coming up on an hour. We covered a whole lot, but hopefully you found that useful. Hopefully there was definitely a lot of information covered. So if you do have questions, let me know down below. But that is networking in Godot, a number of different ways, from simple socket servers to slightly more advanced socket servers using ENet, to HTTP requests, to using the GDScript extensions to do synchronization. But we created a lobby, we created a network game. It isn't the sexiest network game you ever saw, but players were updating on different machines. So if you have any questions, please do let me know. Again, also, if you want to get early access to the book that this material covered, it is up on Patreon, as is all the projects that this was based on are on the Patreon Dropbox, so your support is certainly appreciated there. And you guys watching this video is definitely appreciated. Hopefully you found something to like. Hopefully I kept you awake after an hour long. All right, talk to you all later. Goodbye.